All right, we are live. Welcome everyone to today's Azure Redis community stand-up. My name is Kyle Teegarden. I'm a PM on the Azure Redis team, and I'm excited to be here today. We're going to talk about Redis plus functions today. We have some exciting announcements and a lot of really cool stuff to do as a developer to use these two things together. And I'll say, as always, one, welcome wherever you're coming from. Good morning, good evening, good afternoon. If you have any questions, feel free to put those questions in the chat and I'll try to address them as we go through this live stream. And if you have any questions for after the live stream, feel free to email us at the email address listed there. We're happy to talk with you, get your feedback, answer any questions, etc. So with that, let's dive in. So if you're not familiar with Redis or Azure Redis, it's a super popular caching and data store piece of software. It's used very commonly as a distributed cache, as a way to accelerate an application, as like a layer in between the app and the database, for instance, but also very commonly in other use cases too. Just storing session data or temporary ephemeral data is a growing and very common use case as well, as is more of a messaging or streams type use case. So like communication between microservices, for example, or more of a message broker type of use case. And there's a bunch of other examples there that I won't read out. But I think the takeaway here really is that Redis in general is very flexible, and Azure Redis is just the managed version of Redis on Azure. And so there's a lot of different places that can be used in your architectures. Now, the focus of this presentation is on functions, right? Redis plus functions. So I think the question there is, why does that matter, right? What are the things that are helpful about using functions with Redis together? And I think the best way to tackle that is to first ask some of the common challenges you might have using Redis on Azure. And so here I have a really basic architecture of a very common use case for caching. And this is often called a cache aside or a side cache architecture, where you have your application or an API, maybe that's on App Service, maybe that's on Azure Container Apps or AKS, and you're talking to a database, right? And maybe that database is doing something like storing price data or inventory data for your e-commerce site, common use case. Well, instead of always querying the database for that price or that inventory, it makes a lot of sense to cache that data. And that's like a perfect use case for caching because while you can query the database, if you have a lot of traffic, it's going to make the database much slower. And you can't really use a CDN because things like inventory and pricing, it can be semi-static, but it's not really static. So you want to be able to update it, daily or even hourly. And Redis is designed to kind of offload these read-heavy, common requested kind of applications from a database or from storage and be able to serve those to users really quickly and efficiently. And so adding a cache in this kind of side cache architecture is a way to help your app scale far better and often saves money because you don't have to overscale your databases in order to handle the traffic. The way this kind of works is, right, you have your cache with values from the database that you think will be commonly accessed. Your app will always request that data from the cache first. And if the data is in the cache, then great, you're good. If not, you go back to the database, kind of get the original copy of the data, and then you lazy load that back into the cache. So you have it for next time. Again, very common use case. It's been happening for a while. But there are a couple challenges with this, right? Challenge number one is, how do you figure out what values to add to the cache, right? Like, how do you pre-cache? How do you cache stuff after there are cache misses? What does it look like to load the cache with those values? Number two is that the structure of Redis being a key value store and a database, either NoSQL or a SQL style database like Postgres, those are often different data structures. So how do you translate between the two, right? In Redis, it can be stored as just a basic key value or a hash or a JSON object, or there's a kind of a variety of different data types. And the structure of your data in, say, Postgres or Azure SQL might be a variety of different tables that you're joining together for a query. And so translating between those two is non-trivial, but it really is really quite important. And then the third thing is, time to live, right? So let's say you're caching pricing data. Well, you probably don't want that price to live in that cache forever. At some point, the price is going to change. So how do you handle cache invalidation and make sure that your cache is fresh? And then finally is heavy write scenarios, which is a little more niche, but also a common problem where let's say that I have an application that is writing a ton of things in bursts. That's not a good situation for a database in a lot of cases, but a cache can actually help load balance that and make it a little more effective. So the solution, just to look ahead to a lot of these problems, or a solution, is to use Azure Functions, use serverless functions to kind of offload some of these cycles. And the good news is that we have both triggers and now we have bindings for Redis within Azure Functions, which is like the Azure serverless platform. And so we offer multiple triggers, including things like Redis pub sub channels and key space notifications, along with lists and streams. And I'll mention this in a couple slides, but this covers a huge variety of activity on the cache. So you can trigger on a ton of things. It's very useful. And then we also have input and output bindings now. This is new as of a couple months ago, but basically bindings are a way to make it much easier to take data in and out of a cache. So it just kind of simplifies that whole process. And then like other functions, we have support for a variety of popular languages and documentation around that. And then we have support for premium and durable functions right now. And we're actually rolling out support right now for consumption functions. So the product or the feature that we have is not GA yet. We're just waiting for that consumption function support, but for all intents and purposes, it's code complete and ready to go. So we're planning on GAing at the end of this month. We're kind of waiting for how the rollout of some architectural changes go, but that's the plan. It's GA at the end of this month. So let me talk a little bit about functions and triggers and bindings before diving into kind of some specific use cases and example code. So there's really two types of ways to connect to a function. Like I said, triggers and bindings. And triggers will invoke a new function execution. So it's like something happens on your cache, and that actually kicks off a new trigger. So there's a code example here, if you can read that, where we're triggering on a delete event. And Redis is cool because it has this concept called key space notifications. And that means that you can actually trigger a pub sub event. So it puts a message out on an internal Redis channel every time certain actions occur on the cache. And there's a long list of things, I'll put that on the next slide, that can trigger this. This is an example using a delete event. So basically, what happens in this case with that key event under delete is every time a key is deleted on your cache, it puts out a notification on this channel. And our trigger here is looking at that channel and will trigger every time it sees a new delete event come into that channel. And in this case, right, we're just logging, here's the key that was deleted, basically. But as you can imagine, there's all sorts of things you could do instead of just logging that the key was deleted. Execute your own code. You could repopulate the key. You could trigger another function that does something based on key deletions, et cetera, et cetera. But that's kind of the first concept of triggering, where it's like something happens, we trigger code. And like I said, with key space notifications being part of the pub sub mechanism within Redis, there's a lot of things you can trigger on. So, new keys, updated keys, deleted keys, expired keys, things that you renamed, new items in lists or new items in streams. It's a huge list of things. And so there's a lot of robustness here around configuring your triggers and doing some really cool things with Redis. The second thing you can do with this integration is bindings. And bindings are a little simpler in a lot of ways. It's just an easy way to connect a function to another resource. So there are two types of bindings. There are input bindings and there are output bindings. Think of input bindings as reading data into your function from Redis, and output bindings as writing to Redis, outputted from your function. So here's an example of an input binding. And you can see it's literally one line of code. It's the fourth line there. The Redis input, we give our connection string, and then basically we're saying this is going to be a get command. So we're reading a value as defined by message. And so basically getting that value back, string value. So here we're basically just logging, here's the key that was affected, and then we're pulling the value of that key using the input binding. The reason this is helpful is you don't have to import a Redis client and set all that thing up every time you run a function. It's all abstracted away in a single line of code. And we support both connection strings, like your kind of typical password, and also we support intra ID now to handle these input and output bindings. And so there's a little more security there that can be baked in from using managed identity to connect rather than just a connection string. So another advantage of using bindings and triggers here as part of the integration. And then the second type of binding, as I mentioned, is the output binding. So writing out from the function to Redis. This is an example here. That second line is configuring the output binding. This is all .NET as an example, but we support a variety of different languages for this. So here is set functions, which is kind of a basic write to Redis. And then that last line, the return string, basically we're saying, all right, this is a set command. So it's going to be set, and then this is the parameter. So in this case, we're setting the key new stream entry to the value of true every time this function runs. So basically, we're triggering every time there's a new entry to the stream. We're saying, all right, basically, we've got a variable in Redis of, hey, there's a new stream entry. We're setting that to true. So just the kind of simple examples of how to use bindings to make your application a little easier. All right, let me jump. I have to deal with a couple windows here and just kind of give an example of what this looks like. So I'm going to share my screen real quick. Okay, there we go. So I have a couple examples here. This is a really basic one where I have a function set up. There we go, connecting to our log stream. And I'm running some sample code. You know what? Let me actually just pull up the sample code first just to show everybody. I'll switch to a different screen. All right, we're going to go into VS Code. Okay, so here is some example code. And I actually have two files here with a variety of triggers. This first file has just kind of basic triggers and all sorts of things. So pub sub channels, key events. So like I can trigger every time a key is deleted or created. You can trigger on specific keys. So in this case, I have a key called key space test, and everything I do to that key will be triggered as part of this function. And then functions triggered on lists and streams as examples. And then I have another set of triggers here. So this one will trigger every time I use a set command, it triggers and returns the value that is set using an input binding. In this case, if I have a new entry to a stream, like I showed before, this uses an output binding to write this key, set it to true. So these are just kind of basic examples, and I'll just run through what some of these look like in the real world. All right, juggling back to the other screen. Okay, so this is my function. I've deployed code to this, and we actually have a tutorial that will walk you through step by step on how to get all this set up, and that's linked in the show notes, I believe. And there's a nifty feature in Azure Cache Redis where you can actually use a built-in console for Redis. You can also connect with the CLI or use a tool like Redis Insights, for example, to do the same thing. All good options. But what you can see is if I do something like if I set, all right, let's say get key hello and set it to the value of world. It's kind of like a basic example. Oop, sorry, set rather than get. My bad. So if I get hello, oops, get hello, get the value of world back, right? Common Redis use cases. But since I have a trigger set up on this stuff, you'll see that when I set the key hello to the value of world, it triggered my function on the set command, and actually can see this nice little return. Key hello was set to value world, which is being pulled out from the input binding. And I can do other stuff too, right? If I delete the key hello, it has another trigger. It says, hey, key hello was deleted. And And so, all this kind of stuff triggers these different functions and bindings. I forget the specific. I mean, you can use streams and lists and everything here too. I might skip ahead for the sake of time. I also forget. Actually, let me see. What was the stream test was the name of this key. Let's see if I remember my syntax well. So I think it's add stream test. There we go. So basically what this command does is I have a Redis stream, which is kind of like Kafka. It's like a message broker that stores messages named stream test. And I added an entry with a user named Clippy. And if I go back to my function, oops, I must have used the wrong name. Stream test. Oh, I don't know. Must have gotten the syntax wrong. Anywho, that's another example. I think I got the name of the stream wrong. Anyway, I'll move ahead here to avoid wasting any time since we have a couple other demos. So anyway, so this is just kind of a basic example of how these functions work using Redis and Azure Functions. All right, let me run back to the slides real quick. Okay, here we go. Okay, we are back. Okay, so how does this help you, right? Cool, functions, they trigger cool stuff. You can do cool things with serverless functions, that's great. But what does this look like for you, your job, your hobby, your career, etc.? Well, there's a couple of really good use cases with this. So one is doing something called a read-through cache architecture. And the idea here is instead of having your app kind of have to negotiate of, do I talk to the cache? Do I talk to the database? How do I update the cache with the latest values from the database? You use a serverless function to do this instead. So basically, in this case, what you would do is you would trigger a function based off of a cache miss, which is a key space event. And that would initiate a function that would then pull the data that was missed. So, if you have a key, the price for your Apple item, and that key was missed, it's not in the cache, you would then look into the database, pull that value, and then add it back to the cache. So this is like just a very streamlined and more elegant way to load the cache data into your cache. Like every time there's a miss, you got a function that's going to add it back to the cache. So this is kind of like a basic form of doing this for read through. You also can put a function in front of the cache or use two functions here so that your application doesn't have to worry about the database at all, right? The app could just talk to the function, like maybe use an HTTP trigger to trigger the function and request data from the cache. And then the function itself could query the cache, see if there's a cache miss, pull the data from the database, and then return that data to your application directly. So this way, you use the serverless function with Redis, with your database to totally abstract that away from your application. So no kind of monitoring or polling needed on the part of your app to make sure that it's talking to the right data source. So this just makes things a little smoother in a lot of ways. And again, it helps with the translation problem of, all right, the format I get back from my database is maybe different than the cache. And so your function can kind of handle that complication for you. The other thing that's really common to use this for is to handle consistency between your cache and database, especially with freshness of data in your cache. And so Redis, one of the cool features is that it has some pretty robust functions to handle the time to live, or TTL, of data in your cache. And so there's kind of 4 ways to do this. They're listed here. Expire and expire at are kind of the 2 main commands. And then pexpire and pexpire at are the same things, but a little more precise. Where expire just sets the TTL of an item in your cache, right? So if I say expire Apple 1, if I have a key name Apple, maybe it's storing the price of the apple, I'm saying expire that after 1 second. And you can make that longer, right? If you want it to expire every minute, 60, you can make it expire every month, et cetera, et cetera. But that just kind of sets this generic TTL for those keys. So your data is at least as fresh as the TTL. Other thing you can use is expire at, which sets an absolute time to expire data in your cache based on a Unix timestamp. So if it's like, hey, I know I have a Black Friday sale, but I want these prices to be gone by midnight, the day after Black Friday, you can set that in advance with your cache. And the cool thing is that when these expiration events occur, they trigger expiration events in your key space notifications. And so what you can do is you can use a function to trigger whenever those keys expire and then pull a fresh updated version from the database back into the cache. So that way you never have to worry about your cache not having a copy of that key or that data. It's all updated for you automatically from your serverless function. And I have another demo of what this looks like. So let me go back to my browser. And actually, same thing. I'll share what some of the code looks like. And same thing here. Like we have, there's actually a blog post I just released that shows what this looks like. And we have sample code and even like a bicep template and AZD, easy way to create this, all the resources you need and to upload the code automatically. So I'll put that in the show notes as well. So all this is really doing is we're saying, all right, we're gonna have a trigger right here that triggers every time there's one of these expiration key events. And then within that trigger, we're actually using an input binding for Cosmos DB, where we have our source of truth. That's where we're keeping our official pricing. And we are saying, all right, key is expired. And then we're actually going to query Cosmos to find, okay, we have this key, Redis key. If there's an item that has that same name, let's pull the price data from that and then update that in Redis. And then this actually is an output binding for Redis to update the price. So it's not a lot of code, right? A simple example, but not a lot of code to do a pretty robust thing. And so I'll show you what this looks like in practice. Okay, so basically what I got is I have a Cosmos database that's all set up, just a simple container here. I just put two items in this. I have an item called bread with the price, and an item called apple with the price. It's an expensive apple. And I have similarly a function here, and we'll look at the log stream, has this code uploaded to it, and my cache. And if I go in here, I can say, all right, let's set apple to $1.10, right? And if I get that value, $1.10, great. So what I can do is I can say, all right, we're going to expire that value. And let's give it 5 seconds. We don't want this value to last any more than 5 seconds. So if I say, all right, we've expired, I get apple again, it's still $1.10. That's right, still $1.10. But if I wait a little bit longer, and if my demo works and didn't suddenly break, then if I ask for the value of apple now, it's $2.25. And you can see what happened from the function, right? When I issued that when the expiration happened, not when I issued the expiration command, but when the expiration happened, you can see my function executing, key has expired, and the value has been added to Redis. And I can do the same thing with the other one, with bread, right? And be like, all right, set bread, let's say that's $2, get bread, etc. Let's say expire bread in 1 second, get bread, it's $1.25. Pull the value from Cosmos, and that same function executed. So this is kind of a cool example of what you can do with this. Just help kind of make your life a little bit easier. All right. I'm going to jump back to the slides. Cool. Oh, I got a comment that I'm not projecting anything. Okay. Let me, please let me know if that is still happening. I should be projecting, but I might be doing it wrong. So please let me know. Maybe I wasn't actually putting stuff up. Oh, my bad. I'm super sorry if that happened. Okay, we're going back to the slides here. I think I may not have actually been publishing the window. I just was assuming that was happening. All right. All right, the last example I'll show is using a right behind cache. And just for the sake of people that maybe missed the rest since I wasn't maybe projecting correctly, here's the slides that I was sharing that I missed. So expiration, the architecture diagram, and then this was the read through kind of example as well. So my apologies there. Okay. So the last example right behind. So this was one I mentioned where writes can become a bottleneck with a database. If you have a ton of writes, especially if they're batched together, that can be a lot for a database to process. And so this is an example of using Redis and using the functions integration to handle actually more of a what's called a write behind situation, where your application doesn't have to write to the database at all. It just writes to the cache. And then the cache, using the serverless function, handles asynchronously writing that data to the database. And so, right, the kind of idea here is, all right, I write to the cache, the function's triggered on that set command, and then the function writes new values to the database. And so I will show what the code looks like there, and then I will make sure that I'm actually sharing this stuff. And if you have any questions, please feel free to put it in the chat. Okay, I think it's this one. All right, make sure that is being published. Ha, it was not. Okay. Thank you, Enrique, for calling that out. So here's just kind of some demo code. We have this in our docs as well as a tutorial on how to do this. In this case, there is a SQL binding, I believe now, but I'm not using it. I'm kind of establishing a SQL connection here using the .NET library. And you can see that I'm triggering based on a set command. And then I am using a Redis input binding to get the value of the item that was just set. And when I see a new set happening, I write it to the SQL database. It's kind of simplified query language here. And you can see what happens. It basically adds that key and then reports back, all right, we've added this new key to the database. All right, so I will share my other screen here, and I'll go back and I'll quickly demonstrate the other two things that I think were missed. Okay. Okay, so this is the right behind example. You can see right now I have this. Oops. Gotta re-log in. Cool. All right, so I've created a table called inventory. Oh, and let me make sure I'm sharing my screen. There we go. Boom. Okay. So I've created a table called inventory, just a basic example here in a SQL database. And right now there's nothing in it. And I have this function here that has that code uploaded to it and cache. And what I can do is I can do something like, all right, let's set a value. So I was using Apple before. Say it's another expensive Apple, it's 2.5. I can set that in Redis. And it's here in Redis, right? If I say get Apple, I get the value back. But you can see that that set command triggered a function. And it says key Apple is set with value 225 and added to the database. So if I go back to the database and query it again, you'll see, boom, there's a new item, Apple 225. And I can go crazy doing this, right? I can be like, all right, we got some bread that's $1. We're going to set the price of Apple to be a little bit lower. We're going to have, I don't know, cake. It's $10. And all of these writes are triggering functions. And all of these writes come back to the database. And the cool thing here is that you can, one, it both simplifies your work stream, right? You just have to talk to Redis. And two is that you can use your function to do things like rate limiting. You can connect to the database asynchronously, so it's non-blocking. Like there's a lot of cool things you can do to kind of handle bursts of data through the cache, because your cache is going to have higher throughput than the database is. And so it kind of enables your application to handle many more writes than it would otherwise, especially if those writes are bursty. And since I'm pretty sure you all didn't see the other demos, again, I apologize for that. I just want to show you real quick what those look like. So this was what I mentioned with the Cosmos database. This is the expiration example where I have prices for apple and bread here. My function, you can see these are the past executions, and my cache. Let me reconnect to that. So what I can do is I can say, all right, set apple as 1. I got price of $1 for apple. And if I say expire apple 5, in 5 seconds, that price will be expired. So right now it's still 1. Right now it's still 1. Oh, nope. 5 seconds surpassed and it updated to 225. So it pulled the value from Cosmos right here and triggered a function and updated that value in Redis. And then this was the first one I showed. I won't run back through this because you kind of get the gist at this point, but this is just kind of basic triggers and bindings. Okay. Let me jump back to the slides. All right, here we go. Okay, we are back. The one last architecture I want to mention is more of an event-based architecture. I don't have a demo for this, and it's kind of different every time, but I think one of the benefits of using functions and more event-driven rather than polling-based architectures is that it allows some pretty complicated use cases. I was like talking to one customer, and what they want to do with this is handle their order system, where an order comes in, right? They have a storefront, it's running an AKS, and they use Redis streams as kind of a queue to temporarily handle these orders. And so their app adds something to Redis saying, hey, got a new order. Here's some details about that order in the stream. And they can then use a function to trigger on that order and kick off other applications, right? I can tell their supply chain kind of system and their billing service to say, hey, we got a new order. Here's what you need to do. And then it actually rewrites that back to Redis to store the state of the order, saying, all right, billing, processing, supply chain processing, so that they kind of know where things are at, or if they need to reverse the order, if they need to redo something in the order, right? That's all being stored as a state in Redis. And then when everything's complete, like when the state is ready, then it triggers kind of the final processing to say, all right, order is in the database, it's confirmed, our analytics are being kicked off on this. We're going to text our customers through Azure Notification Hub, et cetera, et cetera. And so, this is just kind of a way to use Redis, but also functions to handle these temporary states in a larger or more complicated process. So I just want to mention this here too as a last example, as something to get the mind thinking of what you might be able to do with this. Okay, so we talked about a number of things, kind of going back to those original problems. If I go back to this slide, right? Like, how do we load the cache with values from the database? You can use functions and kind of a read-through pattern to do that. How do you translate data? Like, functions can be used to talk between key value NoSQL style versus a SQL style, or Cosmos and Redis, et cetera, et cetera. How do you keep cache values from going stale? Like, trigger on expirations and use a function to refresh the data in the cache. And then heavy write scenarios, using serverless functions and a write behind pattern might be a way to solve some of those problems as well. So, these are common problems, and I think functions gives you a tool in your tool belt to solve them. I think there are a couple of caveats that I wanted to mention here too, especially for production applications, right? So one is that it's kind of hard to determine how fast functions can scale. And this is more of a problem for Redis than other things because Redis can handle a lot of throughput. So if you're running at like tens of thousands of requests per second, I would say test it out before relying on a serverless function to scale up. Functions does a very good job with this, but test it first is what I would say. I think the other thing is key space notifications, which we use in most of these applications that I showed, are both fire and forget and async. And so they're not durable. If you miss that notification, it's gone. It makes it simple, but makes things a little tricky. So for key space notifications, you can't use consumption functions. You need to use premium or durable functions. And you should keep in mind that there's not a guarantee that that key space notification is fired before anything else happens on the cache, or that the ordering of those notifications is always correct. So if you expire like 3 keys simultaneously or very close to one another, the ordering of those expiration events might be different, right? It may not align perfectly. So just things to keep in mind. And then the last thing is kind of a fun one. Be careful of circular dependencies. So I ran into this problem building some demos. You can actually make it so that you get a infinite loop where maybe your function is triggered on a new value in the cache, and then the function writes a new value in the cache, which then triggers your function, which then writes a new value, and so on and so forth. And so, just be careful about that and put some guardrails in there so you don't just get into an infinite loop of functions triggering. So with that, again, please feel free to put questions in the chat. If people have any questions here. There's a few resources listed here. I believe there's also show notes, has links to tutorials on how to do this, reference docs, if you want to give this a try to put this all together. And then I'll also put in the chat a new blog post that has both like a bicep template to easily provision all the resources you need, and also Azure developer CLI support. So all you got to do, clone the repo, type AZD up, and it will basically generate that expiration demo for you. So it provisions everything, you're ready to go. And so that's just a way to help you get started sooner, see what this looks like in practice, and then build on that with your own code. So like I said, thank you all for attending. I'm sorry that I didn't present those slides for a little bit. Hopefully you can go back and I showed those slides and take a look at what was missed. I know it's always more fun to see something than just hear me talk. And so my bad there. And then, I'll put the kind of the outro music on, but I'll be on for a few more minutes. If you have any questions, shoot us an email or put it in the chat, and I'll do my best to respond. Thank you so much for attending and for your time. Have a good rest of your day.